So we focused on bonds to oxygen because polar bonds just do much better in infrared spectroscopy. But of course, oxygen is not the only electronegative atom bonded to carbon that we've studied. We've also looked at compounds that contain nitrogen, and it is worth a shorter movie looking at a couple of these. Okay, so the important areas for the bonds to nitrogen, the NH bonds, taking place about the same area as the OH bonds, as you'll see. Carbon-nitrogen triple bond, it's a nice polar triple bond, so we will see it in nitriles. Carbon-oxygen double bond, I'm not going to talk too much about the carbon-nitrogen double bond, and then carbon-nitrogen single bonds pretty much take place in the same area as the carbon-oxygen single bond. So let's compare the spectra of ethanol here, which we've now seen quite a lot. There's the OH, there's the CH, which I'm not even circling anymore. There's the CH bend, just to emphasize where it is, and there's the CO single bond. Let's compare that to ethylamine. So all we're doing is replacing the OH with the slightly less polar NH2 group. And here's what that spectrum looks like. So you can see again, we've got the big, fat, broad NH peaks. We describe them as medium. A lot of times they're actually nice and strong. This is not a very good spectrum. When you look at the baseline of this spectrum, you want the baseline to be as close to 100% transmission as possible. So ethanol, nice here, so the peaks really stick out. But you can see ethylamine, not very much of a baseline at all. But anyway, that's the NH stretch quite happily. There is our bend again. See how it almost really dominates a big part of the spectrum. And then up here is the carbon-nitrogen bond, less strong, weaker, so described as medium compared to the carbon-oxygen bond that we see in ethanol. So you can see there's definite similarities between the OH and the NH2 when you stick them on to an ethyl group. Staying with the rather ugly spectrum of ethylamine, but now let's compare that to another nitrogen containing molecule, that of acetonitrile, in which we have that nitrile, that cyanide group, the C nitrogen triple bond. So that's the spectrum of that. First thing to notice is no big NH peaks there, because of course the nitrogen doesn't have any hydrogens on it. You can see the usual carbon hydrogen area there that's obscured in that big fat NH and ethylamine. But the big important peak that we now see with acetonitrile is this carbon nitrogen triple bond peak down here at about 2,250. So right up the end of the expected range for the C triple bond N. And of course, we don't have the C triple bond N in the ethylamine structure. So in much the same way that with the oxygens, we could see the presence or the absence of the OH bonds, we could see the presence or the absence of the carbonyl bonds, and we could see the presence or absence kind of on the edge of the fingerprint region with the carbon-oxygen single bond. Very important for our nitrogens as to whether you have the NH bond or the non-NH bond, and then in this case the nice carbon-nitrogen triple bond that we don't really see the equivalent of for the triple bond with the carbon-oxygen triple bond. Just to point out the vagaries of infrared spectra. Obviously we've got this peak here which is associated with the bending, big messy area here, some of which we're saying is the carbon nitrogen single bond because we know it's got to be there for ethylamine. We know there's not a carbon nitrogen single bond, but here we are starting into that fingerprint region, some peak there that's undoubtedly associated with the carbon nitrogen triple bond in the same way that these bends here are associated with the twice of the frequency of the carbon hydrogen oxygen hydrogen bonds. So infrared, very tricky to make too much of. You really do just need to get used to looking for the important bits.